Good morning. This recording is for Pre-Algebra Chapter 9, Lesson 6, Circles. All right, so circles have several things going on, like how we name circles. So we name circles by the point in the center. So if this is the point M, then it's a circle M. Now, circle M has an infinite number of points that are all equidistant from the center of the circle. And those are those blue dots that are really hard to see around the edge. All right? So again, a circle is just made up of a ton of points that are all the same distance from one point, and that is the center point. Okay? So things that go on inside of circles and end up on the edge of circles. So chords. Chords are a segment whose endpoints are on the circle. So like there, that green line is a chord. It is a segment, it ends on one end of the circle and on the other end of the circle. All right, and again, it could be a bunch of different places. Like I could have a chord right here, and a chord right there, and I could even have a chord right there that goes through the center. Okay? So, chord starts and ends on the edge of a circle. The radius has one endpoint on the center of the circle and one endpoint on the circle itself, which is the edge of the circle. It stops and does not continue in either direction. So there you go. That's the radius. A diameter is a specific type of chord, like the last one I showed you, that passes through the center of the circle and goes through to the edge of the circle. So right there, that purple line. All right? And then the circumference is the distance around the circle. And diameter is twice the radius. So if I took two orange lines here, two radiuses, and lined them up so that they make a line, they are going to go through the center of the circle and they would form a diameter. So diameter is 2 times the radius. All right, circumference. The circumference is the distance around the circle. All right? Very good. All right, so let's talk about some very specific things that have to do with circles, and that would be the ratio formed by every circle's circumference and its diameter. And it is the same for every circle, and that's pi. Pi, we use either 3.14 or 22/7 as an approximation of pi. But again, this ratio happens with every circle. The circumference divided by the diameter gives you pi. And pi is this crazy symbol right here if you're not familiar with pi. All right? And we've already passed pi day from when I recorded this video, so yeah. Okay. So the circumference of a circle is the distance around the circle and can be determined by using the formula below. We've got 2 of them. We have one of them that uses diameter and one of them that uses radius, because really the difference between diameter and radius is that you can get the diameter if you multiply the radius times 2. All right? So that's why we have 2 different formulas, one using just diameter and one using just radius. But really they could be converted to the same because 2 times the radius is just diameter. Okay, so let's go ahead and move on. Diameter, radius, and the next question is find the circumference. So if we know the diameter of a circle is 2 4/5 inches, we can multiply the diameter times pi to get the circumference. Now, since the diameter is already a fraction, and either there we go. So if the diameter is a fraction, we can use pi as a fraction, which is approximately 3.14. And I'm going to use the approximate sign here. Approximate. It's approximate. It's not exact. It's very hard to calculate pi just because it goes on forever and never stops and never repeats. Therefore, we use an approximation of pi. So the circumference is actually never exactly equal to pi times diameter. It's approximately pi times diameter because it's very hard. Well, excuse me. It is pi times diameter if you leave pi as pi. But if you ever need to change pi into 3.14 or 22/7 to get it turns into the approximate. Now, if I asked, give me the exact circumference of a circle, you would substitute whatever the diameter is, but leave pi as pi. Okay? So if I asked you what is the exact circumference of a circle with a diameter of 2 4/5, I would tell you that, well, I'd convert 2 4/5 into an improper fraction. I would say it was 14/5 pi. And that's the exact circumference. But then if I asked you for an approximate circumference, I would change pi into 22/7 or 3.14, multiply it times 14/5, which is what I'm about to do right here, and that would give me the approximate answer. All right, and I simplified before I multiplied. So the approximate circumference is 8 4/5 inches, but if I, again, wanted to give you an exact, I would say it was 4/5 pi. So there's an approximate answer and there's an exact answer. The exact answer has pi. The approximate answer replaces pi with 3.14 or 2/7 and then does the multiplication, and that gives you the approximate. Okay, so we must use the approximate wavy lines, these right here, whenever we're talking about an approximation of circumference. If you want to use the equal sign, you can't multiply by pi. But don't think that I'm going to let you be lazy right now. I let the Algebra 1 kids be lazy and not multiply by pi and give the exact answer. But for right now, you guys are finding the approximate answer. All right, next problem. We have radius is 3. Well, since I have, or 30 millimeters, but since I'm using radius, I have to use this equation right here. So it's going to be c equals 2 times pi r, where we have 2 pi is 3.14, and r is 30, which is going to give me the approximate circumference of the circle being 188.4 millimeters. All right, next problem. Number 3, diameter being 200 miles. Well, that uses the diameter formula, multiply by pi, which in this case is 3.14, and we get a rough circumference of 628 miles. All right, next one, making circles. Circle graphs. To make a circle graph by hand, you have to find the measures of each central angle. A central angle is an angle whose vertex is the center of a circle. So I'm not actually going to teach you how to use a protractor today, and a protractor is a funny looking thing that kind of looks like a half circle, and it has some measurements on it, and 90s up here, and 0s over here, and 180s over here, and then you have like angle marks between all of them. Then you guys probably know what this is. You've seen one before. If not, I can show you one in class. And if you really want to know how to use it, I can show you how to use it, but it's not something I'm going to have you do today in class, just because there are a gazillion of different apps, and, well, probably not a gazillion, but there's many apps and applications, basically either on your iPad or on computers, that will make a circle graph for you. As you can see, I've made a very lovely circle graph over here using the app Numbers. All right. Now, what I am going to have you do though is figure out the degree measures of each section. All right. Now, you could probably do this using a protractor if it was drawn to scale. We're going to assume it's not drawn to scale, but I also want the full exact measurements. A lot of these degree marks are going to have decimals, and I want the full on decimals, so I'm going to make you calculate them. All right. But before you can calculate them, you need to know something. You need to know first how many total degrees there are in a circle. There's 360. If you have half a circle, that's 180 because it's a straight line across. So right here, so if I have a circle, and if I have half a circle, from there to there is 180 degrees. If I have a fourth of a circle, which is from there to there, I have 90 degrees. All right, and then if I have half of 90 degrees, I have 45 degrees because half of 90 is 45, and just the same as half of 360 is 180. All right, and so you can get obviously infinitely smaller and smaller and smaller until you get down to 1 degree or less than 1 degree, and there you go. Okay, so we're going to go ahead and figure this out. Actually, I'm not going to erase it. I'm going to back it up, because if I don't back it up, I'm going to mess up the things that I've done previously. Okay, the other thing you need to remember is cross product. If you have a part over a whole equaling a part over a whole, you can use cross product to figure out an unknown. All right? So we need to compare the percentages of each item to the whole of the circle. Now, since we're using percentages, basically everything's compared to 100 up here, and I don't really say it, but we say a percentage is 100%. And we could also know that if we add up all the percentages, we're going to get 100%. 40 plus 43 plus 5 plus 12 is 100%. All right? And when you're dealing with circles, you need circle graphs, you need to make sure that you have the total going on. So you actually need to know what the percentage is and what the 100% is. So if 40% is type A, we need to figure out how many degrees 40% of 360 is. Well, we're going to go ahead and make a proportion, which is a part over a whole equals to a part over a whole. So 40% over 100%, so 40% is the part, which is represented by type A, over 100%, which is the entire population, is equal to some degree, in this case x, over the total, which is 360 degrees. Okay? So I'm going to use cross product. X times 100 is equal to 40 times 360. I'm going to go ahead and solve for x. X equals 144 degrees, which means that there are 144 degrees in this section. So if I were to take a protractor and measure from there to there and line it up, it should be roughly 144 degrees. Now again, I don't know how drawn to scale this is. It looks pretty close. You could try putting a protractor on top of my video recording and measuring it and seeing if it comes out. I'd actually be really impressed if it was, so go ahead and check it for me. All right, let's go check another blood type. Let's check blood type D, as I'm just picking random ones. I'm not going in order. Well, we know that blood type D is 43%. It tells it to me inside the graph, and it actually showed it to me inside of my circle graph there. So we're going to figure out how many degrees in a circle is represented by 43% of the whole. So we're going to do cross product. We're going to figure out what x is, and we're going to figure out that x equals 154.8 degrees. And I'm also going to do type C and figure out that type C is represented by 18 degrees, and then type B is represented by 43.2 degrees. So if you were to add up all of these degrees, you should get 360. And I want you to go ahead and do that right this second. So pause the video, add up all of these degrees right here, this one, this one, this one, and this one, and you should get 360. All right, because all of those degrees represent a proportion or a percentage out of 100%, but the 100% is really 360. All right, let's go ahead and do one more together. So, a local high school polled its students asking what their part-time jobs were. Here were the results. Calculate the number of degrees that make up each section of the circle graph provided. So, we had 15 students saying they work at the library, 140 students saying they worked at a restaurant, 60 students saying they worked in an auto shop, 75 students saying they worked at a retail store, and 30 saying they worked at some other type of job other than the ones already listed. Before we can figure out what cross products we need to do, we need to figure out what the total number of students polled are. So we need to add them all up, and we're going to get 320 students, and that's how many students were interviewed. So out of 320 students, we need to figure out what degree measurement that represents in the circle graph provided. So again, part over total is equal to part degree over total degrees. And the part degrees is what we're trying to find every time. You guys can see up here. This is what we're trying to find every time. This is always 360. This is the total number of interviewed people, or the total number of things, and this is the number of people who responded for that particular thing. So for the library, only 15 people said that they worked for the library, but this was out of 320 people, and that's going to equal the number of degrees out of 360 that my total circle is. So again, cross product, and we are going to figure out that the number of library students represents 16.875 degrees. All right. Let's do other next because it's the next smallest, and I'm just kind of doing them out of order, which is fine. And we're going to figure it out that that represents 33.75 degrees. Retail was 75 students out of the 320. Do cross product, and it's going to be 84.375 degrees. Auto shop ends up being 67.5 degrees. And the final one, restaurants, is going to end up giving us 158.4 degrees. The only thing is what did I do different here? Here I used the percentage that was given instead of the actual number. And as you can see, if I add up all those degree marks, it actually does not end up being 360 degrees. And that's because I changed halfway through. I used the percentage instead of the degree mark. So let me show that to you one more time. It represented the percentage instead of the number of people. That changed my numbers. So by changing it back to the number of people who actually said it, I end up getting a slightly different number. So if you look here, this number is slightly different from that number, and it's going to make up for the fact that we had 0.9 extra. So you need to stick with it. You can either need to do the percentages or you do the number of people, but you can't switch between the two. Okay guys, I am done. Have fun with circle graphs.